Okay, so for the last two problems, 43 and 45. 43 is, it's a simple Q equals MC delta T problem, I think, because you have Q, you have Q, you have M, and you have delta T, and they're asking for C. So C equals, uh, what's that? What's that? Q over M delta T. And then you plug those in. Delta T was 55.1 minus 25.2. That's 29.9 degrees Celsius. And then so you just plug in that stuff. So C is equal to Q was 133 joules over M delta T, 29.9. Always remember to match your units. So like for the C in the 6.1 table that's asking you to look at, match those units. It was degrees Celsius, grams, and joules. This becomes 0.89 joules over grams degrees Celsius. This is grams, yeah. And that's aluminum solid. Number 45. This was probably the hardest problem in the this was probably the hardest problem in the problem set. This was, I think you should have learned this from chemistry last year if you're a junior, and if you're a senior, maybe you learned it 2 years ago. I barely remember this. I think it was just Q equals MC delta T, and it's just going to become heat lost equals heat gained, which makes sense because conservation of energy. Remember this principle. So it will become MC delta T equals MC delta T, and the first substance was 30 grams at 280K, and it's mixed in with the 50 gram and 330K. So that would become, so let's just set those out. The one that lost energy is the 50 grams of water with 330K. So that's 50. And then since both substances are water, C cancels out. You can put it in, but it's not really relevant. It's gonna have the same calculation, but you're just gonna have weird decimals because heat capacity for water is 4.18. Yeah. So 50 times 57 degrees Celsius minus temperature final equals 30 times temperature final minus, is that 57 degrees Celsius. And if you couldn't tell, I converted these into degrees Celsius because the numbers would be smaller, and it's not really that hard to switch these into degrees Celsius. You just subtract 273. Yeah, and then 5 times 57. That's my meant. 2850, I think. Minus 50 T final equals 30 T final minus 210. Need my calculator for this one. Yeah, so you just do simple math. 3060 equals 80 T final. Remember, T final is in degrees Celsius. So 3060 divided by 80, T final equals 38.25 degrees Celsius. And in the back of the book, I think it wants you in kelvins, right? This was what, 45? Yeah, it wants it in kelvins. So you just add 273. Yep. So it's 311K. And that's it. That's the hardest part to understand is probably this. The 50 times 57 minus T final equals 30 times T final minus what's that, 7? Yeah. So the way you're supposed to look at it is heat lost equals heat gained. You look at it, it's the 50 gram of water at 330K. 330K was 57 degrees Celsius, and it mixed in with the 30 gram sample, which was at 280K. Which one was the heat lost and which one was the heat gained? It's this one. The 50 gram water was the heat lost, and then the 30 gram water was had the heat gained. That's why these are flipped like this. These two parts are flipped. You see that? And the reason for this is that you want T final to be you want T final to kind of represent the heat loss and the heat gain part. So what was T final? T final ended up being 38.25. Yeah. So plug in 38.25 and then you plug in T final and you kind of get the picture of it, because delta T is equal to the difference in temperature, which is T. It's usually delta T is usually T final minus T initial, and that's the case for this part, right? But it's not the case for this part. The reason for that is because, as I said, like the heat lost and heat gained. You want the T initial, the initial temperature, which was 57, to be less, which is why T final is 38.25. See, this was the initial temperature, and this was the final temperature. You notice that heat that's lost and then the heat that's lost is equivalent to the heat that's gained in this other part right here. Um, yeah, that's basically the gist of why you do that. And then you do the whole flipping thing, cause I just wanted to keep delta t to be like a positive number. Actually, I'm not really sure how this really works. I just know that it's he lost, he gained, and when it's like this, when it's heat lost, you put it like this, the T initial and T final, because when you subtract them, it would become a loss in energy, and then this would become a gain in energy, because this was the initial -7, and then it gained into this, into the T final. If you understand that, yeah. And yeah, there's not really a better way to explain it. Just go with that, and maybe Strom will explain it better. Maybe not, but if you get it, cool.